Welcome to this video on linear algebra project number 1. In this project, we're going to use linear algebra and matrices to solve for the currents in an electrical network. So I've got an electrical network here on the left. What you see is I've got some voltage sources. I've got some resistors. And we've got 4 currents. We want to solve for the currents inside the network. Now we need a few basic facts from physics. By Kirchhoff's laws, the sum of all the voltage drops around this network must be 0. If I go across a resistor, the voltage drop is the current times the resistance. If I go across a voltage source, how I go across the voltage source affects the sign. So if we go minus to plus, we call that minus. And if we go plus to minus, that's a plus. Okay? Or if you prefer, short side to long side to short side. So let's consider loop number 1 here. If I come through resistor 1 ohm here, that's 1I1. I come this way across the 7, so plus 7I1. But notice I1 is going this way, I2 is going in the opposite direction. So that's minus 7I2. I'm coming up this way, 4I1. I4 is in the opposite way, so a minus 4I4. And then I'm going on the voltage source from short to long, and so that's a minus 40 and then back to the start, so that's 0. So if you collect together all of the I1s, you've got 12I1 minus 7I2. There's no I3 involved, so 0I3 minus 4I4, and I move the 40 to the right. So that's my first loop equation. I want to see that in your work as well. Now the rest of these, I just did the same thing. I went around loop 2, keeping in mind how I went across the voltage source, and if I was in a place where, for example, here in loop 2, I2 goes this way, I3 is coming in the opposite direction. Anything not present would be a 0, and so I did that for all 4 loops. All right, and you can see the work there, and I want to see that in your project as well. So we call that matrix formed by using the left sides the resistance matrix. So you see R1 is this first column, R2 is the second column, R3, R4. And if I actually make the matrix equation, it has my resistance matrix, my currents, and then the right-hand sides. Now, you don't have to solve this by hand. Use any kind of software that you like. I solved it using Wolfram Alpha, and you're welcome to do the same. So, it is free. How do you do it? Well, I said row reduce, and then you enclose each of your rows with set brackets, and there's set brackets on the very outsides to generate your matrix. And so you can look here and see, is it correct? And then when it does the row reduction, it puts it in Gauss-Jordan form. Make sure that you select yours to not have fractions. I want decimals. Those are easier to look at. And those are our currents 1, 2, 3, and 4. So that's a sample for what to do and how to do it. So our problem, you're going to tell me your resistance matrix again. What is R1, R2, R3, R4, R5? What does the 5 by 5 matrix look like? What is your voltage matrix? Write down your matrix equation and then solve it and take a screenshot of your solution. So here is yours. There are 5 loops. 1, 2, 3, 4, 5. Do the same thing. You're going to trace around each of these loops, writing down the voltage drops to generate what you have. So I'm looking for neatness. I'm looking for good organization. I want to see your work, how you actually got your loop equations, and your resistance, and this, and any screenshots. Make it nice and neat. Put it all into a PDF file and then email it to me.